So in this video, we are looking at the exemplar questions that one might be exposed to as a result of having completed their required practical on chromatography. So in your lesson, you are going to look at a series of exemplar questions that have been asked as a result of completing a practical in chromatography. Here is one that we're going to go through together, and you're going to apply the skills learnt in this video to the questions that you're going to access in the lesson. Okay. So the question is saying that some farm salmon have coloured additives in the food that they are given. This is a permitted additive that improves the colour of the fresh meat. Okay. A sample of the colour is extracted from the salmon. Explain how paper chromatography could be used to confirm that this is the permitted additive. So when we're actually looking at past paper questions, one of the useful things to look at, which is available online, is the examiner reports that come with the question. So if you look at this examiner report, it's saying that it's only the better answers that actually recognised how chromatography can be used, and many people got very confused with their answer and didn't recognise that this was a question related to a practical that they had done. Very often this is the required practical style question is asked in the exact format of what you did in the practical. So you are given chemicals which have a known identity. So for example, a green dye, a black dye, a yellow dye, a blue dye. And you are asked to compare that with an unknown dye. So what you would have done is you would have drawn a pencil line on the chromatography paper. And obviously you're drawing that pencil line because you can't draw ink, because ink will run and that will interfere with your chromatogram that you develop. The second thing you have to recognise is the solvent line needs to be below your dots that you spotted, otherwise the dots won't run. And then once you allowed the chromatogram to run, the spots travelled a particular distance depending on their affinity to both the chromatography paper and the chromatography solvent. And those dots, you could calculate the RF, and the RF value was just the distance travelled by the spot divided by the distance moved by the solvent. So you would have had to make sure that you drew your solvent line, so how far the solvent went up the paper. And you measured the distance travelled by the solvent and the distance travelled by the spot, and that gave you your RF value. And you could see here, for example, that in my example, that the dye that goes into substance what we've called black is exactly the same thing that goes into yellow, because they have the same RF value. Okay, but the unknown has two spots, so it has that spot that's in yellow, but it also has the spot that's in green. Okay, you are now asked to apply that practical that you've done to a new scenario. So in the question, the first thing you needed to recognise was that you were going to spot the additive, okay? That is the agreed known additive. And then you were going to spot the colour sample that you'd taken from your salmon. It said in the question that there was some colour sample that was dissolved from the fish meat, okay? Again, you would have run it in a solvent. Again, the solvent line would have to be below the pencil line of your chromatogram to allow it to run. Again, you would have had to mark off how far your solvent went up, so that would be your solvent front, how far your spot went up, and again you could calculate the RF value, okay? And if they were the same chemical, they would have the same RF value. So your first mark was for mentioning that you had to use a solvent. The second mark was for mentioning that you had to spot both your additive, that is the chemical, synthesized chemical, and the colour that you've got from your salmon on your chromatography paper. You let it run. They would run a particular distance depending on their affinity to the solvent and to the chromatography paper. And then your final mark was for saying that if they were the same thing, they would have exactly the same RF value. Okay. You could extend that, because you guys are top set, you could extend that to say that they would have exactly the same RF value in a range of solvents. Because remember, we said that one of the limitations of chromatography was that they could have very similar RF values in a particular solvent, but that may just be a complete coincidence. It may not be, because they're exactly the same thing. But if they have the same RF value in a wide range of solvents, then obviously they would be the same thing. So what you're going to do now is look at exemplar questions which have been asked as past papers, and apply what we've done here to look at how you might approach those questions.